What was people's conception about the Earth's shape back in ancient time? The Sumerians were the first historical civilization who were capable of writing, and they accepted the fact that the Earth was flat. Perhaps it was the appearance of the plain land that persuaded them that if you somehow evened out all the elevations and depressions, you would be left with flatness. Also, if you look at the camp pond and lake water, it looks pretty flat on a quiet day. Another way to look at it is to ask, what is the curvature of the Earth? Well, if you measure, you will find out that the curvature of the Earth is 0 to the mile. But as of today, we all know that the flat Earth theory was wrong. Terribly wrong. But back in ancient period of time, it was nearly right, and that's why the theory lasted so long. Eventually, there were reasons to find the flat Earth theory unsatisfactory, when at about 350 BC, a great Greek philosopher named Aristotle found it impossible to explain three different phenomena he observed with the flat Earth theory. He observed that some stars in the sky disappeared if anyone traveled to the north or to the south. During lunar eclipse, Earth's shadow on the moon was always the arc of a circle. The hull of the ships traveling in any direction in the Earth disappeared first. All three observations could not be reasonably explained if we assumed the Earth as flat. Also, Aristotle believed that all solid matter tends to move towards a common center and thus ending up as a sphere. About a century after Aristotle, another Greek philosopher named Eratosthenes noted that for the same object, sun casts a shadow of different lengths at different latitudes instead of being the same length. From the difference in shadow's length, he calculated the circumference of the Earth, and he found out that the Earth is of about 25,000 miles in circumference. The curvature of such a sphere is 0.000126 per mile, which is very close to zero and was quite impossible for the ancient to calculate without any advanced equipments or advanced knowledge. And that's why the theory lasted so long. But yet, is the Earth a sphere? Well, not in the strict mathematical sense. However, when Jupiter and Saturn were observed by the first telescopic observers, it became quickly apparent that they were not true spheres, they were something else. In fact, they were more like an ellipse. Isaac Newton, towards the end of the 17th century, showed that a massive body, if it were rotating, a centrifugal effect would be set up that would lift the body's substance against gravity, and this effect is greatest at the equator, introducing some oblateness. Actual measurements of the Earth were carried out in the 18th century, and Newton was proved correct. So, the Earth is an oblate spheroid, and the oblateness of Earth is 0.0034 to the mile. Well, then what is the Earth's curvature? It's 0 on a flat surface and 0.000126 on a spherical surface, and on the oblate spheroidal surface, the curvature varies. It varies from 7.973 to 8.027 inches to the mile. The amount of correction in going from spherical to oblate spheroidal is much smaller compared to going from flat to spherical Earth theory. So, holding the belief that the Earth is a sphere, even though it is wrong, it is not as wrong as the flat Earth theory. Similarly, most of the things we know might be incomplete and may become incorrect one day. In much truer or subtler sense, most of the theories we found wrong these days were actually incomplete, just like a missing puzzle piece.